Hello, good afternoon students. Welcome to one more amazing session from Infinity Lane by Sri Chaitanya. How are you all? This is Suresh, Faculty of Chemistry from Infinity Lane. Today we are going to discuss about the Arin's electrophilic aromatic substitution reactions. How are you all? Can you all able to see me? Yes, confirm in the chat box. Just give a thumbs up and fire emoji in the live session. Yes, students, how are you? Anamani is there today? Welcome. Right. So before going for the session, just a small description about what Infinity Learn is doing for the students preparing for NEET examination. I just want to exemplify a list of students here: Ashrita, Akhil Verma, Hemadyuti, Sachin Narayanan, and they got, just to see the comparison of the scores between 2023 and 2024 NEET examination. Here Ashrita, she got 310 marks, and after studying the courses from Infinity Learn, she attempted NEET examination and she got 661 marks. You see how much score she increased. And Akhil Verma, he got 313 marks and she increased 658 marks. And Hemadyuti, 310 marks in 2023 and 652 marks in 2024. There is an increment of 342. See the scores, like Sachin Narayanan got 330 marks and he secured 650 in 2024. 320 marks बढ़ गया. You see, almost the score is doubled, and I want you to be like, not only these four, hundreds of students got like this. So I want you to be in the same slide in 2025 NEET examination. Are you ready? Are you ready? Yes, you can do it. And also, I just want to say, crack your NEET examination and grab your medical seat. How it is? Yes, it is possible. Just like attend the class daily, on daily basis from Infinity Learn YouTube channel, and like, share and subscribe. What late? And you can see SEO test prep with Infinity Learn. You have live classes, mock test, create your own test, and 24 by doubt resolution. And also we are on social media, and you can join, and the social media links are available. And also join our Telegram channel, especially link is given in the description box, my dear children. Infinity Learn NEET, in the Telegram channel you have daily quiz, you have session schedules, you have session notes bhi milega, har din ek assignment hai, and many more to follow. Link is given in the description box. And a super amazing thing, Infinity Learn, India's first artificial intelligence enabled learning platform is created. AI tools are in the coaching industry. So India's first. Why not? You will be having all the process like doubt resolutions for 24/7. And also self-study packages are there, live streaming and test paper analysis, what not, everything is there. And the self-study program, your program, let's learn, practice and revise, everything is available. So it is guided by AI tools. And also very important thing, India's largest scholarship examination score. It is there for you people preparing for NEET examination. You may be a grade 11 or a grade 12, you are eligible to write this, and you may be related to in Infinity Lane or not, you are eligible to do this. And why it is India's largest examination? Just give me 2 more minutes so that I can start the concept. So we are going to learn the concept just like a formality. I just want to discuss this. Scholarship worth of 1 crore, and study setup and laptop will be given to you, and educational allowances bhi hai, and up to 100% scholarship. You just check it in the description box and pinned messages. Just click the score examination and you can write the score examination online and every week and anywhere, and you can just get all these score examination registrations or attempt from 9th October, say, every weekend. Okay, and also Diwali gift for you. NEET 2025 All India Test Series package, which silent features includes 27 AITS examinations and 20 full test mock tests and 25 topic wise tests be available here, and 3 PCB with video solutions on the app, performance reports and benchmarking with Sri Chaitanya. Actually this was actually 5,999, but for Diwali gift Infinity Line is giving to you 50% slash, just YouTube 50 off. You just apply that coupon code. Once you apply that coupon code, YouTube 50 off, the automatically the 5,999 will come to 2,990, 50% slash. Ready and enjoy this. So this is about AITS NEET 2025 test packages. And while it will start about the arenes, what you learn, aromaticity is very important topic now. Today topic is going to be electrophilic aromatic substitution reaction. For that you need to know what is aromaticity and benzene golden reactions, and what let everybody take a pen and book and start writing along with me, and we'll be doing some questions, awesome questions also, and we'll be discussing about the mechanism, and I'm going to give you simple tricks to understand and apply the questions to crack the NEET examination related to the NCERT textbook. Are you ready? Right, everybody give a fiery emoji and thumbs up in the chat box. Get ready. And also will be introduction to the structure of benzene, preparation of benzene aaj ka nahi hai, and electrophilic aromatic substitution is the major main course for today's class, and directive influence of mono-substituted benzene, and this is a super awesome topic. You are going to get NEET examination based on this and based on this. Okay? And also you are going to see aromaticity. That's a very important. Let's discuss about what is aromaticity. In this aromaticity, the compounds has characteristic aroma. Such compounds are called aromatic compounds. So my question is, does the compounds have the characteristic aroma or classified based on that aromaticity? Not like that. So aromaticity is a completely different concept. Of course they have the characteristic smell, and the reactions of an alkene, if you consider the reactions of an alkene that you consider, alkenes are unsaturated hydrocarbons. So when you treat with an alkaline cold KMnO4, it is going to give diol, vicinal diol. So this is the basic reaction of an alkene or alkyne. Due to any compound with carbon to carbon multiple bond can give this test. But when you talk about the benzene do not give like this. So benzene do not give like this because of the aromatic resonating aromatic nature. Benzene has the resonating structure like this. So resonating structures of benzene, in the ring the electrons continuously revolve, delocalize. There is a sustained continuous current of the pi electron system in the benzene. Benzene इसका प्रॉपर्टीज बिल्कुल अलग है. जैसे इसका 3 डबल बॉन्ड है अंदर, लेकिन आल्किन का तरीका रिएक्ट नहीं करते क्योंकि उसमें रेजोनेंस है, एरोमेटिसिटी है. एरोमेटिसिटी का वजह से ये इसका पाई बॉन्ड अवेलेबल नहीं है. आर यू गेटिंग और नॉट? एंड आल्सो you can say if the direction of the ring current is diatropic, then the molecule is aromatic. If the direction of the ring current is paratropic, then the molecule is said to be anti-aromatic. और अब देखने वाला aromatic, non-aromatic and anti-aromatic कौन सा चीज़ होगा? So classification of compounds are classified into aromatic, anti-aromatic, non-aromatic as far as the cyclic hydrocarbons are concerned. And in that, let us talk about the conditions for the aromaticity. It's a बहुत काफ़ी इंपॉर्टेंट है. So conditions for the aromaticity, it should be cyclic structure and should be planar, and there should be a ring, the ring must be planar, and there is no atom of the ring must be sp3 hybridized. अगर आपका नेगेटिव चार्ज लोन पेयर ऑफ इलेक्ट्रॉन होगा तो सो sp3 रूल इस्तेमाल ना करना. Okay, so if that electron is there in the lone pair or the negative charge, don't consider the sp3 hybridizer condition, right? And also ring, it should be fully cyclic conjugated, and in the cyclic system the resonance should be complete, not half, it should be complete. If anywhere it is missing, the delocalization or resonance is missing, you have to ignore the aromaticity. Okay, it should follow Huckel rule. I mean to say 4n plus 2 number of pi electrons should be there in the delocalized system. So this number of pi electrons you have to conclude for this delocalized pi electron. उसमें क्या, and example n is equal to 0 अगर मान लो, and we will get the following 4n plus 2 is equal to pi. I mean to say 4 into 0 plus 2 and is equal to 2 pi electrons, therefore the ring with 2 pi electron is aromatic. How it is? First let us talk about the previous one. You just see, this is your benzene. Let us say the first point is okay, yes. Ring must be planar, yes. Benzene is sp2, 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 all are sp2, so that it is planar. So each sp2 is a planar, and it must be fully cyclic conjugated ring, is completely having a resonance, and it must follow Huckel rule. So 4n plus 2 is equal to how many electrons are there in the delocalization? 2 electrons, 2 electrons, 2 electron. एक बॉन्ड का मतलब है उसमें एक इलेक्ट्रॉन जोड़ी होगा, है ना? So that 6 electrons are there. So it on solving n value, therefore n is going to get 1. So agar n value 0, 1, 2, 3 in integer होगा तो aromatic होगा, 0 नहीं होगा तो aromatic नहीं होगा. And if you say aromatic and non-aromatic and anti-aromatic, you see these are the 4 points, है ना? These are the 4 points. 1, 2, 3, 4 points are okay and okay, okay, okay. Such compound is said to be aromatic. Okay, if any point is missing, then you can say it is a non-aromatic. And very important point, my dear children, carefully you observe, if it follows the first point, second point and third point, and unfortunately fourth point is missing, such systems are weird and it is said to be anti-aromatic. That is what you call it is anti-aromatic. उसमें कौन सा ज़्यादा स्टेबल होगा? बच्चों आप बोलना एरोमेटिक, एंटी एरोमेटिक, नॉन एरोमेटिक में कौन सा चीज़ ज़्यादा स्टेबल होगा? चार्ट बॉक्स इस्तेमाल करो बेटा, आप आंसर सीधा दे सकते हैं, फटाफट देना. सो द ऑर्डर ऑफ स्टेबिलिटी, aromatic more stable, non-aromatic is more stable, and anti-aromatic is more stable, anti-aromatic. अरे बेटा anti-aromatic highly unstable, formation of anti-aromatic compound मना है, एग्जिस्ट करते हैं नहीं, हाईली अनस्टेबल. अगर ये रिएक्शन में जहाँ पर आपका जो इंटरमीडिएट है और प्रोडक्ट है एंटी एरोमेटिक प्रोडक्ट बन रहा है तो इसका एनर्जी ज़्यादा से ज़्यादा होगा एंड इसका स्टेबिलिटी कम से कम होगा। ऐसे इंटरमीडिएट एंड प्रोडक्ट्स फॉर्म करना मुश्किल है। ओके, सो इन नेवर फॉर्म दैट काइंड ऑफ थिंग, राइट एवरीबॉडी? Everybody, please give a fiery emoji and thumbs up in the chat box, dear children. Good. So let's see various examples here. If n is equal to 0, kaise n is equal to 0? Cyclopropenium ion, yes, इसका resonating structures कैसे होगा? ऐसे भी होगा resonating structures. So if you consider like this, yes, it is cyclic planar and complete delocalization and all the 4 points are okay. So 4n plus 2 is equal to how many electrons are being delocalized? Just 2 electrons. On solving n is equal to 0. 0 भी permitted है उसमें, so that it is aromatic compound. It is aromatic compound. मान लो पिछले एग्जाम्पल का ये n is equal to 1 है, बेंजीन का एरोमेटिक होगा, देखो n is equal to 1, then there is 6 pi electrons, बेंजीन का जैसे। n is equal to 2, then there are 10 pi electrons, naphthalene, and n is equal to 3, there are 14 electrons, anthracene। समझ में आ रहा है क्या बेटा? अगर कुछ डाउट है ना तो चार्ट बॉक्स में आपका क्वेश्चन फटाफट देना, so that I am going to explain you the question as well as answers. So benzene, let's talk about if more than 2 pi orbitals are parallel and the orbitals are simultaneously, there is a conjugation given, one of them is filled and other way is going to be vacant. Why? Because bonding and anti-bonding molecular orbitals are there. So we have characteristics of aromatic compounds. They have a characteristic smell. There is a characteristic smell. The smell may be good or bad. Okay, they have extra stable. Aromaticity introduces extra stability for the molecules, mind it. And they burn with sooty flame. What is the meaning of sooty flame? Sooty flame means the lot of black smoke with the flame is called sooty flame. Why? The aromatic compounds burn with a sooty flame. If anybody give the answer in the chat box, fast. Because the aromatic compound do have high carbon to hydrogen ratio, so that they burn in a sooty flame. Okay, and also classification of compounds: aromatic, anti-aromatic, non-aromatic. Aromatic फिर भी उसमें एक अलग क्लासिफिकेशन है, बेंजीनॉइड का एरोमेटिक, नॉन बेंजीनॉइड एरोमेटिक कंपाउंड। बेंजीनॉइड एरोमेटिक कंपाउंड का एग्जाम्पल बेंजीन स्ट्रक्चर का जैसे आ गया, एंड नॉन बेंजीनॉइड उसमें बेंजीन का स्ट्रक्चर नहीं होगा, बेंजीन का जैसे स्ट्रक्चर नहीं होगा। ओके, सो दैट इज कॉल्ड azulene. Okay, that is called azulene. And benzenoid molecules having at least one benzene ring in a system is known as benzenoid aromatic system. Example: naphthalene, anthracene, phenanthrene. They have number of pi bonds. Here 5 pi bonds, 10 pi electrons. And anthracene 3 rings, 7 number of pi bonds, so that each pi bond contains 2 electrons, 14 pi bonds are there. And also you can see phenanthrene, you have the structure is same as this, but the ring का position उल्टा फुल्टा हो गया, इसका बाजू में है, so that 7 pi electrons, 7 pi bonds, 14 pi electrons. Hope you are understanding. And also you can see anti-aromatic compounds. The anti-aromatic compounds, these are unstable compounds. First of all, whenever anti-aromatic comes into the mind, you simply say it is unstable. And conditions for anti-aromatic, they must be cyclic, and they must be planar, everything first point okay, second point okay, and third point be okay, and unfortunately fourth point it is not accepting Huckel rule. है ना बेटा? And there must be 4 n pi electrons where n is equal to 1, 2, 3 and so on. Got it beta? Any doubts? And 1,3-cyclobutadiene is a cyclic planar system. You have, this is a cyclic planar system. In the cyclic planar system, you have the 4 pi electrons. When you do so, 4n plus 2 is equal to 4 pi electron. N is not equal to an integer, it is going to be 1 by 2, right? So, it is an anti-aromatic system, and so non-aromatic compound, everything is fine, but nothing is confirmed here. And let us talk about the order of stability. ये ऑर्डर का हिसाब से आपका क्वेश्चंस पूछा जाएगा बेटा. And aromatic compound is more stable than non-aromatic compound is more stable than anti-aromatic compound. Anti-aromatic compound never and ever exist. And which of the following is an aromatic hydrocarbon? I want the answer in the chat box. Dear children, I want the answer in the chat box. I want the answer in the chat box. Anybody can give the answer. And where I can see, and it is an anti-aromatic, this is anti-aromatic, it is aromatic, and it is non-aromatic. Why? Because here I got sp3 carbon, planarity is missing. Simply by looking at the structure you can say. Here I could find sp3 hybridization, it is non-aromatic. It is non-aromatic. Okay? And my answer is going to be this. Which of the following is an aromatic hydrocarbon? Yes. Based on what is the order of stability of the given compound? Anybody? Give the order, give the order, give the order. Okay. Now, this is an aromatic, and this is anti-aromatic, and this is a non-aromatic. This is a non-aromatic. So, the order of stability, aromatic 1 is more stable than non-aromatic 3 is more stable than anti-aromatic 2. That is the order. And also, based on the characteristic aromatic compounds, why do aromatic compounds burn with a sooty flame? So, they have relatively high percentage of carbon, high carbon to ure, high. Chart is now provoked here. Hello, how are you? So, they have high carbon to hydrogen ratio. Yes. So, what you are charting, I do not understand. Come on, you say something, I can understand you. What is that? Language or emojis? Okay. You come, let us say, this is a super important topic, quasi-aromatic compound. Do you have any idea about the quasi-aromatic? Yes, quasi-aromaticity is very important. In this quasi-aromatic compounds which are positive or negative charges present in the ring, a part of Huckel rule can be followed, are known as quasi-aromatic compounds. In this case, like a trophyllium ion cation, this cation is aromatic. If this is not a cation, this is not aromatic, it is non-aromatic. and cyclopentadienyl anion is aromatic. In this quasi aromatic, I just want to say one important thing here. Cyclopropenyl cation is a quasi aromatic. Dear children, stay along with me, and I am discussing so many important concepts, and along with an examples also. You all please attend this and follow this, and characteristics of quasi aromatic. I will give one more example here. I will give one more example. When you talk about cyclopropenone, this structure is actually aromatic. How it is aromatic? Once this electron system is shifted from here to here, because oxygen is more electronegative. In this scenario, it is going to be in the equilibrium in between two structures. Okay, you will be getting a structure like this. Now this part is going to be quasi aromatic compound. This is going to be quasi aromatic. Are you getting or not? Clear? So they are highly stable, and as this is aromatic, equilibrium always try to lie in this right side. Got it, Yuri? Hope you are understanding. Come on. So they are soluble in polar solvent. Why? Because they have the charges. It is soluble in the water, and they have high dipole moments. Because of its dipole moment bhi zyada hoga iska, and they have high boiling point and melting point because they are ionic in nature. They form stable salt. Are you getting or not? And moving ahead, based on the stability, out of these compounds, which is more stable? You tell me. You just mention the answer in this chat box. Mention the answer. This is trophyllium ion cation, and this is benzyl cation, and this is stabilized by resonance. Of course, a खुद aromatic था, and this is stabilized by resonance. ये resonance stability के वजह से ये aromatic बन चुका. So that trophyllium ion cation is more stable than benzyl carbocation. Got it? Fine. And based on stability, out of the compound, which is more stable? Cyclopentadienyl anion and benzyl anion. Cyclopentadienyl anion is more stable due to resonance. Fine. And resonance and aromaticity, and also reactions of benzene. So benzene, when treated with, carefully you just observe, benzene when treated with bromine in carbon tetrachloride. Okay, I just want to say here, this is your cyclohexene. If you add with the Br2 and in the CCl4, you are going to get bromine over here and a bromine over here. So it is a red color of the bromine water is going to be disappeared. While on the other way, if you consider the benzene here, benzene due to aromaticity, Br2 and CCl4, no reaction. No reaction takes place. Why no reaction takes place? Due to aromaticity, benzene का reaction बिल्कुल अलग होगा. Okay, let's discuss about what are the benzene reactions. Benzene, its structure, you consider the benzene. Okay, so the benzene, its structure is like this. because of this, pi electron systems are delocalized. It is going to give the structure like this. If you see the structure in this dimension, it is seen in this dimension. This is your benzene, and there is a delocalized pi electron system can be seen here. This is your delocalized pi electron system. This delocalized pi electron system can be seen above and below the ring of the hexagon. This is what you call it as delocalized pi electron system. Due to this delocalized pi electron system, this benzene is highly resistant for addition reaction, rather they are susceptible and prefer to undergo electrophilic substitution reaction. So, we are going to start with electrophilic aromatic substitution reactions. So, I just want to say electrophilic aromatic substitution reactions is the main course of the benzene reactivity. So, in this scenario, most important reactions of benzene in the electrophilic aromatic substitution reaction, that is, you can say SE substitution, electrophilic, or otherwise A electrophilic aromatic substitution, EAS, okay, or otherwise substitution AR, okay, E. You can say various symbols are there to say. So, benzene always prefers to undergo aromatic substitution reactions. So, what is this? One of the hydrogen from the benzene is substituted by an electrophile. This is your electrophile. This is your electrophile, okay. And in this you can say various reactions, okay. First, the pi electron system of the benzene attacks the electrophile, so that you are going to see this is attack of the electrophile is the rate determining step. So, that you are going to get a pi bond is become a sigma bond. It was a pi bond था, अब ये sigma bond बन गया. You see, that is what happened in this rate determining step. So, that it is resonance stabilized. So, a carbocation is formed. It is resonance stabilized, a carbocation is formed. And in the step 2, the conjugate base is going to take the hydrogen over here, so that a proton is released. So, a substituted product by the electrophile is seen. So, this is an electrophile is substituted the hydrogen, so on the benzene ring. So, it is called as electrophilic aromatic substitution reaction. So, this is what you call it as a sigma complex. This sigma complex is the intermediate in this reaction, and the formation of a sigma complex is the rate determining step in this reaction. And let us see various reactions. The 5 most common electrophilic aromatic substitution reactions of the benzene, they are halogenation and nitration and sulfonation and Friedel-Crafts alkylation, and it is a Friedel-Crafts acylation. These are the 5 reactions. So, in these 5 reactions you can see halogenation करने के लिए bromine, chlorine, iodine substitution takes place. Nitration, nitro group substitution takes place. Friedel-Crafts alkylation and acylation, they are going to substitute these. And let us talk about the bromination. When benzene is treated with bromine in the presence of FeBr3, bromobenzene is formed. उसमें electrophile क्या होगा? So, that is very important. Bromine अगर FeBr3 से react होने तो brominium ion is formed. So, that brominium ion is the electrophile in this reaction. Are you getting or not? Clear? Any doubt? You read your weird name and we are chatting. So, my dear children, please be active in the chat box, so that I can raise the energy of the system. Okay, another one, chlorination. In this chlorination, Cl plus is generated, Cl2 react with FeCl3. So chloronium ion, Cl plus is the electrophile in this reaction, and that reaction, benzene is treated with Cl2 and FeCl3. You are going to get chlorobenzene. Henna? And also iodination, when iodine is treated with benzene in the presence of HNO3, you are going to get I plus, so that iodobenzene is formed. Here HNO3 is used as an oxidizing agent, and the reaction may be reversible. To stop that reversibility, that HNO3 is more often used. And also you can see in iodination, oxidizing agent like HNO3, HiO4 are used to oxidize HI, which act as a reducing agent. So NEET प्रिपरेशन का ऐसे पॉइंट्स स्टेटमेंट वैलिडेशन के लिए इस्तेमाल किया जाएगा. So whenever the concept is going on, you should be so stringent about the reasoning type questions in the NEET examination based on NCERT. NCERT में कुछ लिख देता है लेकिन इतना डिटेल नहीं देते हैं. So हम डिटेल ढूंढ के रखना. So no worries, I am here to help you. You all can do the best, right? Okay. Nitration. When benzene is treated with nitration mixture, you are going to get nitrobenzene in this. So nitric acid is going to accept a proton from the sulfuric acid. So sulfuric acid is an acid and is a proton donor, is a proton acceptor, Bronsted base. ये HNO3 is a powerful strong acid, but it is acting as a Bronsted base. ये अलग कहानी है, बहुत बिल्कुल important topic है. So that you are going to get NO2 plus as an electrophile. This NO2 plus electrophile is going to attack on the benzene, so that the electrophile is going to be NO2. बहुत काफ़ी important point है बेटा, NO2 plus. Are you getting or not? So which of the following is an electrophile in nitration? Means NO2 plus only, that is only the electrophile. Are you getting or not? अगर कुछ doubt आने तो पूछना हो बेटा, 1 minute. अगर कुछ doubt आने तो पूछना. और complicate लग रहा है ये क्या? ना 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 ना. E is a logical question. He is an electron pair donor and it is a H plus acceptor. So it is a Lewis base as well as a Bronsted base. All Lewis bases and Bronsted bases are same. And this is the H2SO4. This H2SO4 H plus इसका देते हैं. So H plus and donor is a Bronsted acid. Okay. Any doubt, children? Moving ahead, hi Suresh Kumar, Aryan, Are, you have a doubt, you please tell me. Yeah, I am going to repeat it. Suresh Kumar, so far you kept quiet, why so? How are you? First you tell me, how are you? Okay, what is your doubt? Then you tell me. Here, this is the nitric acid. This electron pair on the nitric acid is given to H plus. So, is a electron pair donor. Nitric acid is a Lewis base, and of course it is taking a H plus. So nitric acid is accepting H plus. So it is going to be a Bronsted acid, while sulfuric acid is donating H plus. It's a Bronsted acid. Understand, Suresh Kumar? Clear? Any doubt? Aryan, what is your doubt? What is your doubt? You please post your doubt. Okay, moving ahead. Sulfonation. In the sulfonation, you have sulfuric acid. This sulfuric acid is, again, it is a protonated self-protonation, autoprotolysis takes place. Yes, in this autoprotolysis, you are going to get sulfur trioxide. I mean to say, sulfur trioxide is an electrophile in this reaction. Yeah, in this sulfur trioxide, the pi electron system, the vacant orbital on the sulfur act as an electrophilic center, so that what happens, you know, when benzene treat with concentrated fuming sulfuric acid, you are going to get benzene sulfuric acid. So, sulfur trioxide is the reagent in this reaction. Okay. Now, so sulfonation of benzene is a reversible process. ये NEET एग्जामिनेशन में बहुत काफ़ी important topic है. So a reversible reaction. Okay. So in this reversible, if the benzene sulfonic acid is heated in dilute acid, then the reaction takes place in the reverse direction. In this reverse direction, benzene sulfonic acid when it is hydrolyzed in the acid media and boil it, you are going to get benzene. Why? Because this bond can be easily broken. Are you getting or not? Clear? सुरेश कुमार, आर्यन, आपका कुछ डाउट बोल रहे हैं आप? कुछ डाउट? सुरेश, you are so serious. Why today? How about your preparation? How things are going on? What about your confidence level? Okay, right. Now let's talk about introduction of alkyl and acyl group in the presence of catalyst. It takes place by Friedel-Crafts alkylation and Friedel-Crafts acylation. You have AlCl3 catalyst इस्तेमाल कर सकते हैं, Lewis acids, FeCl3, SbCl3 or protonating agents like HF, H2SO4, H3PO4 can be used as a, okay. And when benzene is treated with alkylation, when benzene is treated with alkyl halide in the presence of AlCl3, you are going to get a alkyl benzene. Okay, दर्द कर रहे हैं, क्यों दर्द है? Why so? आपका प्रॉब्लम है, बोलो बेटा, पहले आपका प्रॉब्लम बोलो. So I'm a good motivator, I am a good counselor, I am a good teacher, I can tell you whatever you want, okay, but classes तो नहीं पढ़ेगी. क्यों? हर दिन क्लासेस चल रहे हैं ना इन्फिनिटी लर्न यूट्यूब चैनल में, आप आ सकते हैं ना सुरेश कुमार, हर दिन रिपीटेड टाइम टेबल. अरे मैं आपको कुछ मदद देना चाहता हूँ, अगले बार आप टॉपिक बता दीजिए, सिर्फ आपके नाम मेरे क्लास लेना चाहता हूँ. अरे क्लासेस बिल्कुल फ्री है ना, कुछ नहीं चाहिए आपके साथ. मैं बच्चों लोग को कुछ भला करने का कोशिश कर रहा हूँ. ओके, अच्छा सोचा अच्छा होगा, क्योंकि आपको कुछ मेडिकल सीट आने का कोशिश कर रहे हैं ना. आई वॉन्ट टू जस्ट पुश यू, राइट? Right? Are you with me? Right? Definitely, I am with you, Suresh Kumar. Aryan, expecting a doubt from you. Okay. Now, let us say benzene treated with methyl chloride in the presence of AlCl3, you are going to get methyl benzene. You can say it's a toluene. And what about RCl? R plus is an electrophile. कैसे? That aluminum chloride is an electron pair donor, acceptor, Lewis acid, and it is going to be, so R plus and AlCl4 minus, so electrophile is formed, right? That's good. And acylation, note that in the above reaction is achieved with an alcohol with HF or diluted HCl. कैसे होगा? कैसे होगा? An alcohol, let me say this. an alcohol or OH. OH group is a poor leaving group in the presence of an acid. मान लो ये भी acid होगा, ये भी acid होगा, and it is going to be, you are going to see R OH2 plus, ठीक है, and it is going to be dehydrated. As water molecule is eliminated, you are going to get R plus, है ना? It is an electrophile. Understand? So organic chemistry is such a simple and you can do it. But when you just fear with organic chemistry, you can't do it. So try to be alert. Yes. So opportunities wait. Gear up your NEET success. Enroll now in the NEET test series. It is there in this short box. You all click it and you will get it. Okay. And an alkene in the presence of HF or H2SO4, you can say CH3, CH double bond, CH2 in the presence of an alkene H plus. What happened? You are going to get a carbocation like this. Understand? Any doubt? Next. Acylation, Friedel-Crafts acylation. These are all electrophilic aromatic substitution reaction. When benzene react with acyl chloride, you are going to get acyl benzene. So acetyl chloride is phenol you are going to get. What happened when acyl chloride, let us say benzene, this is your benzene, benzene is treated with CH3, C double bond OCl in the presence of AlCl3, you are going to get acetophenone. You are going to get acetophenone plus HCl. How this electrophile is going to be generated? Look at the CH3, C double bond O and Cl, the lone pair of electron on the chlorine takes AlCl3 is a Lewis acid, electron pair isse ye lete, so that this bond is going to be broken. So as a result of this, super stable acylinium is going to be formed and AlCl4 plus. That acylinium ion when reacted with benzene, it is going to give rise that acetophenone. If it is a benzoyl chloride, benzophenone is going to get as a product. Right now, let's talk about RCl, AlCl3, acylinium ion, and you can also get in the various forms. Acetic anhydride can also give acylinium ion, either this method or this method. So method बदलते हैं लेकिन process नहीं बदलते हैं. So let's talk about one more. Aryl and vinylic halide cannot be used in the Friedel-Crafts reaction because they do not form carbocation. So when you want to take this, there is no reaction. This is an important for the NEET examination preparing students. Okay, NEET में ऐसे questions, कौन सा questions आते हैं जाते हैं ऐसे. Which of the following reaction is wrong, which of the following reaction is right, kind of things are very useful. Okay. And in substituted benzene, Friedel-Crafts reactions gives poor yield when the electron withdrawing group is present. The groups present on the ring, this includes जहाँ पर बेंजीन ग्रुप का ऐसे ग्रुप्स लगा होगा नाइट्रो, साइनो, कार्बोक्सिलिक, okay, acetyl and trichloro, okay, and sulfonic groups are present. The ring is super deactivated. They are going to get less reactive towards electrophilic aromatic substitution. Which of the following group is ring deactivating group? So we need to know the answer for this, right? Children, any doubt? And in Friedel-Crafts alkylation, most stable carbocation is formed. Okay, Tanza, hi, you are from hi, because carbocation determines the rearrangement. And also you can see when this chloropropane or this propane is formed. So, in the real Cl3 it forms a carbocation, the carbocation is going to get a rearranged product if possible. Yeah, yes, it is real. It is real. Hello, Tanza Adler Helming, it's real. You are from Germany, I am from India, Hyderabad, Infinity Land. We are discussing about the chemistry here. Yeah, you all join, enjoy here. So, one more important point, intramolecular Friedel-Crafts reaction and alpha and beta or gamma alkyl alkanoic acid or alkanyl chlorides gives cyclic products. Okay, so how it is going to yield cyclic products, you can see. And let's talk about this one. Let us talk about this one. This chlorine is lost and it is going to form a carbocation. This carbocation is going to attack from here to here and it is going to give the product like this. So, when a carbocation is formed, it can undergo intramolecular Friedel-Crafts reaction, mind it. And also direct influence of this mono substituted benzene. This is a super important point for the NEET examination point of view, right? If this is real, okay, you can ask a question, but be Tanza, be clear. What about your question? Is it real means what is the meaning of that? Does reactions that I am discussing in takes place in is real life? Yes, it is takes place in real. Or else, what is the other way of your asking real? Okay, okay. Anyways, you please be specific in your question. Let's talk about the wherever ring activation is there, there are ortho and para directors. Wherever ring deactivation is there, it is a meta director. And ortho and para directors, they can be strongly activating group like NH2 or primary amine, secondary amine, alcohols and oxide. These are strongly activating. Moderately activating if cross conjugation is there. They are moderately activating. And alkyl group is a weakly activating. And let's talk about weakly deactivating. Halo groups are deactivating, but ortho and para director, that is an exception. And meta director, wherever direct pi bonds are there, moderately deactivating. Wherever the C double bond O are there and their nitro, NR3, CF3, CCl3 reverse hyperconjugations are there, strongly deactivating. Okay. And also I would say classify the substituent activating, deactivating, activating, yes it is deactivating and it is deactivating wherever minus M effect is there, deactivating. CLF3 super deactivating and it is also super deactivating and it is activating because of the positive hyperconjugation is there, lone pair of electron is there, therefore it is a plus mesomeric effect. Wherever plus mesomeric effect is there, it is an activating and a lone pair of electron is there, so that a plus mesomeric effect it is activating and the electron is going away from here, minus mesomeric effect, deactivating. So, like that you need to look at the structure and you can say whether it is activating or deactivating. Understand? Is very, very, very important. So, just to see a simple trick I just want to give, a simple trick I just want to give. Whenever the benzene if you have a lone pair of electron on the atom directly attached to the benzene, that can be given to the benzene. So, it is your positive mesomeric effect. That is a super trick. That is a super trick. It's a live class. It is not a recorded class. This live or recorded whatever in my class every day 1:30 plus 5:30 GMT or Indian Standard Time morning. It is afternoon 1:30, 13:30 hours the class is going to be. So, now whenever if pi bond is there, okay, C double bond O and a hydrogen, the electron is going away from this oxygen. So, this is your negative mesomeric effect. That is the trick actually. If the electron is coming on the benzene, it is a positive mesomeric effect, so that it is ortho and para director and it is ring is activated. When the electron is going away from the benzene, it is a negative mesomeric effect and the ring is deactivated and it is a meta director. Any doubt? Super tricks. And if the ring is activating, if the electrophile is attack on the A, it is going to get ortho and para director. If this is deactivating, it is going to give just meta director, and it is the simplest version, right? The rate of reaction is toluene is faster than the benzene. Why? Because toluene is ring activating. Whenever reaction is whenever ring is activated, reaction become faster. And also you can say rate of reaction of nitrobenzene is less than that of benzene because of its deactivation. Wherever deactivation is there, it is going to be less reactive and electrophile should attack at meta position. And also rate of reaction of chlorobenzene is less than that of benzene, but it is ortho and para director. It is an exception. However, it is ring deactivating, it is ortho and para director. And also electrophile attack at a ring which is activated. So, it is a substituted benzenes. Okay. So, this is just see नेगेटिव mesomeric effect. ए रिंग का इसका वजह से ये वाला it is a positive mesomeric. This is a positive mesomeric effect. This B ring B is going to decide the upcoming product. So, it could be here at ortho, here at para. So, that is going to decide the product. Understand? Clear? Any doubt? So, in the NEET examination, this type of questions you have to prosect. Okay. Among this ortho and para is going to be the major. Why? Because incoming electrophile has less repulsion, whereas in ortho little bit of more repulsion. And also methyl group is there, nitro group is there. So, when nitration happens, this is going to be strong minus I effect and this is going to be positive hyperconjugation. So, this is going to win, this will not decide. So, this is respective to this ortho and para. These are the two major products can be expected. Fine. Hope you are loving the class today. Suresh Kumar, you kept quiet. Tanza, Annamani. Very good. Why you keep quiet in the class? Okay. Next, let's talk about if two substituents direct different positions, like you say this is at meta position, here it is going to have only minus I effect and it is going to plus I effect plus hyperconjugation. Mind it, ortho it do not operate resonance. So, he will decide which product, which direction the product should be given. Activating वाला decide करते हैं कौन सा product देना है. And also you can say If the two substituents direct at different positions, the electrophile follows the orientation of the activating group like this. That's what we discussed. And if we check here, this is your positive mesomeric effect and this is your negative mesomeric effect. Electron is going away. So that he will decide which product should be formed. Charan Kaushik, you please retract your message or otherwise I will delete you. I will delete you. Suresh Kumar, any doubt? So that with respect to this and this and these are the products that can be given. So the product is given. What is the correct answer for this question? What is the correct answer for this question, my dear children? Suresh Kumar, what is the correct answer for this question? I already given the hint. Already I have given you the hint. So according to that, we can get the product based on this. This cannot be the product. This can be the product and this cannot be the product and this can be the product. And this is going to be the major product. This is going to be the major product. Fine. And identify the correct order of reactivity in the electrophilic aromatic substitution. You want to say this? Okay. Toluene is positive inductive effect and a positive hyperconjugation effect. Okay. Strong minus I effect and weak plus M effect, and it is going to be strong minus M effect minus I effect. So that 2 is more reactive than 1 is more reactive than 3 is more reactive than 4. That is the order, right? Fine. Or a question hai. Okay. So based on this type of reactivity, the questions are asked in the NEET examination. Ring activation, whenever positive mesomeric effect is there, ring activation takes place, the product is going to be ortho and para directors. Whenever electron is withdrawn, negative mesomeric effect takes place, that is going to be meta director. Whenever ortho director is there, ring activates. Whenever meta director is there, ring deactivates. Hope you understand. Right. So today we discussed about aromaticity, benzene reactions and directive influences and kind of electrophile substitution reactions and their orders of the reactions. Okay. So please like this session, subscribe to YouTube Infinity channel and share with your friends, and we are going to meet with more stuff in the upcoming session. Okay. Thank you very much. We will meet in the next session with more stuff. Thank you. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye bye. God bless you.